Have you ever heard of a secret number, a number that holds a key to understanding shapes? This number is called pi. We write it with a Greek letter, pi. Pi is truly special. It's not just any ordinary number, it's a mathematical constant. This means its value never ever changes. It stays the same, no matter what. This makes pi a reliable friend in the world of mathematics. It helps us unlock many mysteries hidden in the shapes around us, especially circles. So, what exactly is this mysterious pi? Imagine you have a perfect circle. It could be the lid of a jar, or perhaps a bicycle wheel. If you measure the distance all the way around the edge of the circle, that's called the circumference. Then if you measure the distance straight across the circle, passing through its center, that's the diameter. Pi is the number you get if you divide the circumference by the diameter. No matter how big or small the circle, this ratio is always pi. It's a universal truth for all circles. One of the most fascinating things about pi is that it's an irrational number. This sounds a bit strange, doesn't it? It means pi cannot be written as a simple fraction like 1/2 or 3/4. If you try to write pi as a decimal, it goes on forever and ever. And it never falls into a repeating pattern. The digits 3.14159 just keep going randomly into infinity. Mathematicians have calculated pi to trillions of decimal places, yet there's no end in sight. This endless nature is part of pi's allure. Why do we care so much about this endless number? Pi is incredibly important. It's not just a curious number for mathematicians to study. It appears in many areas of science and engineering. It helps us design buildings. It helps us understand waves like sound waves or light waves. It even helps us study the stars and planets. Pi is a fundamental building block of our understanding of the universe. Its presence is a hint of the deep mathematical patterns that govern our world. Circles are everywhere we look. Think about the face of a clock, or the coins in your pocket. Even the pupils in your eyes are circles. Pi is the secret code that helps us understand everything about these circles. Without pi, measuring circles accurately would be incredibly difficult. It provides the essential link between a circle's different properties. Pi turns the mystery of circular shapes into something we can calculate and predict. It's like a magic key unlocking their secrets. Let's talk about the circumference again. That's the distance around the circle. If you know the diameter of a circle, you can find its circumference using pi. The formula is simple. Circumference equals pi times diameter. Or if you use the radius, which is half the diameter, its circumference equals 2 times pi times radius. So, if a bicycle wheel has a diameter of 70 centimeters, its circumference is approximately 3.14159 times 70 centimeters. That's about 219.9 centimeters. Pi makes this calculation straightforward. Pi doesn't just help with the outside of a circle, it also helps us find the space inside it. This space is called the area. The formula for the area of a circle is area equals pi times radius, or A equals PR squared. So if you have a circular pizza with a radius of 15 centimeters, you can find its area. It would be approximately 3.14159 times 15 centimeters times 15 centimeters. This equals about 706.86 square centimeters. That's a lot of pizza. Pi gives us the power to measure this space precisely. So, pi is the magical connector for circles. It links the line that goes around the circle, the circumference, to the flat space it encloses, the area. This single, constant number pi holds the secret to both. It shows how different parts of a circle are related in a beautifully simple way. Every time you see a circle, remember that pi is there, silently defining its properties. It's a fundamental constant that makes circular geometry elegant and understandable for everyone. You might think pi is only interested in circles, but pi is a bit of an adventurer. It likes to explore and appear in other geometric shapes too. This shows just how fundamental pi is to the world of geometry. It's not confined to 2 dimensions. It pops up when we start thinking about 3-dimensional objects as well. This makes pi even more fascinating. It's like a golden thread running through many different mathematical ideas. Consider a perfect ball, or a sphere. Think of a football, or even our planet Earth, almost a sphere. Pi is essential for understanding spheres. If you want to know the surface area of a sphere, the formula is 4 times pi times radius squared. And if you want to calculate the volume of a sphere, the amount of space it takes up, the formula is 4/3 times pi times radius cubed. See, pi is right there, playing a crucial role in measuring these beautiful, round, 3-dimensional shapes. What about other 3-dimensional shapes that have circular parts? Think about a can of soup. That's a cylinder. A cylinder has two circular ends and a curved side. To find the volume of a cylinder, you need to know the area of its circular base, which uses pi, and then multiply it by the height. So, volume equals pi times radius, squared times height. Pi also helps find the surface area of the cylinder. It's a key ingredient in understanding these common objects. Even shapes like cones, such as an ice cream cone, rely on pi. The volume of a cone is 1/3 times pi times radius, squared times height. Notice pi is there again, helping us measure the space inside the cone. Beyond perfect geometric shapes, some scientists have even found that the ratio of a meandering river's actual winding length to the straight-line distance from its source to its mouth often tends towards pi. Pi truly gets around in the natural and mathematical world. Now let's meet another very special number. It's called the golden ratio. Like pi, it has its own Greek letter phi. The golden ratio is approximately 1.618. It's also an irrational number, meaning its decimal representation goes on forever without repeating. This number is famous for appearing in nature. You can find it in the patterns of sunflower seeds, or in the spiral of a seashell. It's often associated with beauty and pleasing proportions. The golden ratio is all about proportion. Imagine a line divided into two parts. If the ratio of the whole line to the longer part is the same as the ratio of the longer part to the shorter part, then that ratio is phi. Artists and architects have sometimes used the golden ratio in their work. They believe it creates aesthetically pleasing designs. From the Parthenon in Greece to paintings by Leonardo da Vinci, some say its presence enhances beauty. It's a number that whispers of harmony. So we have two amazing irrational numbers. Pi approximately 3.14159, and the golden ratio, phi approximately 1.618. Does this mean they are directly related in a simple way? For beginners exploring mathematics, it's important to know they are distinct. There isn't a straightforward formula like pi equals phi times 2 or something similar that connects them in an elementary way. They each arise from different geometric and mathematical contexts. Pi comes from circles, while phi comes from specific proportions and growth patterns. However, the fact that both pi and phi are fundamental irrational constants that appear in diverse areas of mathematics and the natural world is itself a source of wonder. They both represent deep underlying mathematical structures in the universe. While a simple, direct link isn't obvious, mathematicians do find complex relationships between many constants in higher mathematics. For now, we can appreciate pi for its role in circles and geometry, and phi for its connection to proportion and growth. Their separate mysteries contribute to the endless beauty of mathematics. Pi in particular remains a cornerstone of geometry, forever unlocking the secrets of circular and spherical worlds.